So in this video is an exercise 11H question 5. So we have the diagram, which is a sketch of the curve with equation y is equal to x sine x. And in part A, we want to write down the coordinates of points A, B, and C, which are basically the roots of this sine graph. So, this is not exactly a sine graph because it's x sine x. So we just need to solve the equation x is equal to g of x is equal to 0, which is x sine x is equal to 0. So in terms of the roots, one of them is 0, so because that's just the origin. And also when we solve this equation, when sine x is equal to 0, basically, when we have pi and 2 pi, we'll still get the same answer, which is 0. So pi and 2 pi are the next natural solutions to this case. So yeah, for solving this, we just need to use intuition to some extent, because I'm just using the properties of sine. Right, so these are the three solutions, and here so is pi, and then here is 2 pi. So we want to write the coordinates of A, B, and C. So A is simply the origin, B is pi 0, and C is 2 pi 0. Okay, so for part B, we want to find the area of the shaded region. Right, so remember that if we want to find the area of the shaded region, we need to integrate the area under the curve. Now, in terms of integration, we'll have to split the diagram. So first integral will be between 0 and pi, and the second integral will be between pi and 2 pi. But remember, the reason that we do two separate integrals is because the second part, the actual curve, is under the x-axis, and there is a problem with that because that's going to give us a negative output. But remember that area is always positive, so we just take the modulus of that, which gives us positive. So that's why we split them, because if we just solve a single integral from 0 to 2 pi, then that positive and that negative are going to cancel each other out, and we will get a value for the area that is less than the actual value. And sometimes if the two parts are equal, we just get 0, which is not correct. Okay, so that means we have basically two integrals. So the first one is between 0 and pi for x sine x dx, and the second one is between pi and 2 pi of x sine x dx. Okay, and this is integration by parts. So let u be equal to x. So du by dx is therefore 1, and then dv by dx is sine x. So that means v is equal to minus cos x. Okay, so now we just need to solve this integral. So we'll have uv outside in the integration by parts, which is minus x cos x, and don't forget the limits, minus, now inside we have 1 times minus cos x, which is just minus cos x, but we can write the negative outside and just have positive cos x inside between 0 and pi. And the same thing applies to the second integral as well. So remember that when we solve this integral, then this just becomes minus x cos x pi 0, and then here we'll have, so cos x integrates to sine x, and then the limits basically. So and also if we just solve the second integral, which is between pi and 2 pi, we'll get exactly the same answer. So it's just going to be basically well, let me okay, write that here. So for pi and 2 pi, we'll get the same answers obviously, so minus x cos x. The only difference is that the limits are this time different. 2 pi and pi. Right, so the answer to the first one, which has limits of pi and 0, when we substitute and we add them, we'll get pi as the final answer. And for this one, we'll get minus 3 pi. So the one that is below the x-axis. But as we said, we always take the modulus of that. So that becomes pi plus 3 pi. And the final answer 4 pi, because area has to be positive.